What's up, guys? This is Codeversity, your channel for nonstop coding action. In today's video, we're going to be covering C# programming language. With no further ado, let's get started. Alright, so the intent of this video is to give you the in-depth view into the C# programming language. We're going to keep things rather simple in this crash course. We're going to be covering the fundamentals of C#, variables, objects, classes. Don't worry if that doesn't mean anything to you right now. If you're an absolute beginner, you should be able to follow along with this course and kind of understand a little bit more about how C# works. And the good thing about C# versus other languages anyway is that it's based on the C programming language. So a lot of what you'll learn today may apply to other programming languages such as JavaScript and even in some cases Java. Even though things may be a little different in some cases, overall things are quite similar. So let's get started. I just have a couple of slides to go over. I promise I won't bore you. So basically, what is C#? C# is a programming language created by Microsoft. It runs on the .NET framework. The .NET framework, we'll get a little bit into that shortly, but generally on a higher level, the .NET framework is utilized to create apps across different platforms, such as desktop platforms, mobile, and even in some cases outside of .NET, C# is being used to create games, like for example on the Unity engine. So C# is a very robust language, and .NET is just the framework that it runs on. So now you might be asking, what is .NET? .NET is a programming framework created by Microsoft, and it's used to build apps for various types of platforms, mobile, desktop, and so on. And .NET is very powerful in the sense that it comes pre-packaged with a lot of classes as part of its class library. You also have the CLR, or the Common Language Runtime, which drives the program execution as well as just-in-time compiling, or JIT. And how JIT works is basically your computer needs to understand a set of instructions that it's given. When you write code in C#, you're giving instructions to your computer to carry out a series of actions. And basically JIT converts that C# code or intermediate language into native language that your computer understands, otherwise known as bytecode. So as you can see, .NET has a very, very important role to play in program execution, building apps, and so on. So why should you use C# as a software developer? Well, for one, C# is an event-driven language. So essentially that means you can build very robust and powerful applications using events. An event is basically an action that gets triggered by another action or another condition. So a common example is if you have a value in your application that when a certain condition is met, it will fire an action or an event, for example, like a database record update. That's a common example of an event that can occur in C#. And events are also a common sort of framework or common foundation in many other programming languages. But in C#, there's a very robust way of writing events. However, we won't be covering that in this course because we're going to keep things a lot simple. But comment below if you'd like me to do specific videos on how C# events work. So I talked long enough about the theory, and I guess you guys are ready to jump in, so let's start coding. So the very first thing that you want to do is you want to make sure that you have a code editor to write your code in. Now, when speaking about C#, there are several code editors that exist out there that do support the C# and .NET framework. However, the most common one that we typically use as C# developers is Visual Studio, which is also created by Microsoft. So you want to do a search for Visual Studio on Google or any other search engine, and then you'll come across this website here that I have open. And on this website, it may look a little bit different depending on the time that you'll look at this video, but generally you want to look for any installation file for Windows or Mac. And I definitely recommend using a Windows PC to develop C# code, but it is doable on Mac, and I do prefer the UX on a Mac, so that's the reason why I'm going to use a Mac in this course. But generally at the time of this recording, we're looking at Visual Studio 2022 as being the current version. So you would want to find the community edition, which is right here on the far left. So that's a free download. You don't have to pay anything. If you want to upgrade to the other editions of Visual Studio Code, you can absolutely do so for a fee. I'm not really sure what the pricing structure is, so you'll have to read a little bit deeper into that. But I think the community edition is sufficient enough for you to do your development on. Now, if you're on a Mac, you definitely want to download this Visual Studio for Mac edition here. This is also a free download. It doesn't have all of the bells and whistles that the Windows version has, but again, in this video, I'm going to be using the Visual Studio for Mac edition since we don't really need to do anything super complicated anyway. So then when you click on that link, and I'm going to click on Visual Studio for Mac here, the free download button, it'll take me to this page, and then I'll have to complete a series of steps here to download the file and install it. Now, I already have it installed here locally, so I won't be doing this again, but you'll definitely want to follow the prompts here as well as the instructions and get that set up on your local machine. And from that point, you can then jump in and we can start coding. So now before we proceed, can you please do me a favor? Pause the video, hit the subscribe button and bell icon to stay updated on future videos. That definitely helps the channel, and I'll create a lot more videos like these based on your feedback and your love. So let's go ahead and get started with Visual Studio. So right now, as you can see, I have open Visual Studio. I've already clicked the icon below to open up the program. Right now, as it stands, we haven't really done anything yet. But what I want to do is I want to create a brand new Visual Studio project. There is something called a solution, which is essentially a collection of projects. And I'll explain that in a bit further so you can have a better understanding of that. So again, guys, I'm on a Mac right now. So on a Windows, this may look quite different, but essentially it's the same process. Just Google exactly how to do this on Windows, and I'm sure you'll find the instructions on how to do it. So right now, what I'm going to do is click the new button here to the right. And when that opens here, we have various different options of what we can select. We're going to just create a basic console application, which essentially means that this application will run within the Visual Studio editor itself. So we wouldn't have to worry about building a web page and displaying any output to like a UI or something like that. So I'm going to select that. I'm going to click continue to proceed. So on this screen here is asking us to confirm additional configurations for our console app. We're using the .NET 7.0 version at the time of this recording. If the version is higher by the time you do this, don't worry, it should still be the same process. If not, just Google it and you should be able to figure it out. And so I click continue, and then on the next screen here, we have the project name. So let's call this C#. Sorry, can't type today. C# crash. So a little bit of insight on solutions versus projects. A solution, as I said before, is a collection of projects. So in a real world application, you may have something like one solution that contains 2, 3, or even many projects within it. And a common architectural pattern that you'll see in .NET is something called the MVC pattern, which essentially means you would have a database layer as one project, another project as your business logic layer, and then another project as your UI layer. And all of those layers pretty much communicate with one another. So that's a very common thing you'll see in the .NET world. So in our case, we're going to build a very simple solution that would have just one project within it. So I'm going to proceed here. I'm going to leave the location as default and everything else as default, and I'm going to click create. So that'll just take just a second here. And as I click create, you guys will see that Visual Studio would open up and there will be some default code in here. For now, don't worry about this code because we're going to get rid of it. I'm just going to talk a little bit right now about the project structure. So it's pretty much simplistic because that's what we're handling right now. We're only dealing with a very simplistic project. But on the left-hand side here in the folder browser, you'll see various folders and files. So our project is named C#, as I said before. We have this connected services folder. You don't have to worry about that, but if you wanted to add additional dependencies and services within it, you can do so right here. A lot of it is automatically populated depending on the types of components that you work with. You also have here a dependencies folder. That's basically referring to the .NET dependencies or third-party dependencies that would be added to this project. But again, for this course, we won't really have to deal with that folder, so you can ignore it for now. And speaking of ignore, we have the .git ignore file, which is infamous for those of you who are experienced software developers. This is where you can add specific references to files or folders that you don't want to commit to Git repositories. So if you don't know what that means, don't worry about it. I can possibly do another video on how Git works and things you need to know for Git if you're not knowledgeable in Git. The main file we're going to concentrate on here is the program.cs. The .cs extension stands for .c#, and essentially this program file is usually the very first file in a console application that runs. So this is the file we're going to be working with right now. All right, the very first thing we're going to do here is get rid of this existing code because we're going to be writing everything from scratch. Now, you guys can just follow along and type along. I think that's the best way to learn, is to actually follow along by typing, or you could just simply watch it and drink a cup of coffee. So just relax yourself and just learn as we go along. So the very first concept I'm going to cover here is called namespaces. So a namespace is basically a set of classes that are separated by name, and that might mean nothing to you right now, but just to explain it as simply as I can, in C# applications we have the concept of a class, and a class is basically a blueprint or template for an object in C#. So for example, you might have a class called animal, or a class called person, or a class called classroom, anything that you can think of. Well, we utilize namespaces to separate classes that may share the same name across the application. And we generally do that to avoid collisions. So for example, we may have a person class and a namespace called courses, and a person class and a namespace called employee. So that's generally a way to separate our concerns within our application and avoid conflicts. So the first namespace I'm going to bring in is called system. Now, the system namespace contains many helpful .NET classes that we can utilize, and one of which is called the console class. The console class itself has many different methods that we're going to be using today, such as writeLine, which would output a single line with a new line at the very end to the user within the console pane. So that's one class we're going to be using today. It's called console, which is part of the system namespace. So now that I've explained namespaces, we can jump right into the meat and potatoes of everything, which is the actual coding. So in this class, what we're going to do is we're going to model this file as a standard console application, which contains a main method call. So I'll explain more after I write a few lines out. So the very first line we're going to write out here is called class, and we're going to call this program because that's the name of this file that we're working with. And we're going to use these squiggly braces, if you will, which is a left curly brace and a right curly brace to open up a code block. And in this code block, we're going to specify a set of instructions to give to our local machines to output data or to carry out a certain behavior, if you will. So within this class, the very first thing we're going to put in here is a main method. So let me just type this out here. So the first thing we'll type out is called static void main. And I'll explain what this is in a second. So the very first thing here is we have this static keyword. And what that means is static means that whatever we have static on, whatever method or class that static is on, this will be loaded into memory once. That means that this particular function will not be reloaded into memory on every single instance creation or instantiation. What would happen is it will be loaded once into memory and we can utilize it over and over again. And one key concept here is we're going to be calling various methods or functions within this main method to carry out different behavior. One thing I'll point out is that whenever we have functions that are contained within the same file, this being the program.cs file, we'll also have to mark those other functions as static in order for this to work. If we're calling other classes, we can mark those as non-static, which I'll show you later on. But just keep in mind that any function or method that we define here would have to be marked as static for it to work. The void keyword just simply means that this function, whatever we write within these braces, it will not return any value. So basically the program or the computer is not expecting to see any value being returned from this method. And lastly here we have the main. So basically this is the name of our method. It's called main. In C#, it's normal convention to capitalize the very first letter of your method. But in this case, we want to mark this as main because actually our computers in the .NET framework recognizes this method as the starting method of the application. So it must be named this to make things a lot simpler. Okay, good. So now that we've explained that, let's move on to what we want to do first. So I guess the very first thing we want to do is output something to the console just to make sure that things are working properly. So let's create, how I'm going to do this is I'm going to create several different methods that will be called from within the main method, and then we'll define those methods below to make things nice and clean. So the very first method I'm going to create will be called print to console. So let's type that out, print to console, and below that I'm going to now create a method of the same name, and this will be the method signature. So again, as I mentioned, we have to define this as static. So static void print to console. And guys, as I'm typing these things out, I'm definitely going to be making mistakes. That's just a normal part of being a developer. So, please bear with me, because those things happen. And to be honest, you learn from your mistakes as well. So I'm still learning today and I'm very seasoned. So that's something to keep in mind. Okay, so we have this print to console function. So the very first thing we want to do is we want to display, let's just say, a message to the user. So maybe we'll make this a hello world application. This is a common thing we do in development. So let's output hello world to the console. So to do that, as you remember, I brought in the system namespace above. So because I did that, I don't have to say system.console. I can simply just say console, and then the console class has a writeLine method. So console.writeLine, as you can see, our auto suggest is already pulling up the correct method. So I'm just going to hit enter on that. And every single line must end in a semicolon. Every single line that specifies a method call or a variable declaration, which we'll get into later, must end with a semicolon. So make sure you do that because C# is very particular on those things. So within this writeLine method call, we need to give it an argument value. And so the value that it normally expects is something called a string. And a string in C# is basically created with double quotes. So whatever text we put between these double quotes will be the value that we're sending to the writeLine method. And as I said before, we want to create a hello world application. So let's just say hello world. Cool. And let's save that. And you can save that on a Mac by doing Command S. I think on Windows it may be Control S, but don't quote me on that. There should be something within your menu above on Windows where you can actually save the file, maybe an icon or something like that. But if you're not sure, when in doubt, just look it up. So now that I have that, I'm going to run this application just to make sure that things work. And to run this on a Mac, there's a short key, which is basically Command, Option, and Enter. So let's try that. It may take a while to build because it's the very first build, but there you go. As you can see below, it's outputting hello world. So that's basically how we output information to the user. Now, the console class also contains helpful methods to take in user input or to do various other things. For this particular course, we're just going to be working with outputting things to the user, outputting data or various strings and things like that, just to keep things nice and simple. All right, so with that being said, let's continue. So in C#, we also have the concept of variables and data types. So what a variable is a space within your computer's memory system that holds particular values. And basically variables are important because it allows us to avoid code repetition and redefining code over and over again. So I'll give you an example, but the very first thing we're going to do is we're going to come back up here to our main method, and we're going to define another method called variable or variables and data types with a semicolon. Now, as you can see, I'm getting an error message because this does not exist. So what I'm just going to do is I'm just going to copy this for brevity, copy this method called name. I'm going to come below the closing bracket of the print to console line, and I'm going to define a new function called static void and then variables and data types and hit enter. So now we have our new method here. Now in this method, we're going to be doing several things. In this method, we're going to demonstrate how variables work and exactly what you need to know with working with data types. So the very first thing I'm going to show you is data types. So in C#, every single object or every single value you'll deal with will have some sort of data type attached to it. Either it will be a built-in data types like integer, like string, like character, Boolean, which is a true or false value, or it could be a data type that you define yourself. So let's start with the very primitive or basic data types first that are coming together with the .NET framework. So the very first thing we have here is an integer, which is a number, is a whole number. So if you think of 0, 5, 10, 100, 1000, these are integers, and an integer can be signed or unsigned. So in this case, we are going to define just a basic integer, and we'll just call this integer age because we want to define the age of a person. So int age, let's say int age is 30. So this is basically assigning the value of 30 to the variable age, which is a number or an int, the int data type. And let's just make sure that this is working. So we're going to console.writeLine age. Okay, and we're going to save that, and then we're going to do our shortcut key, and we'll run this. And as you can see below, right below the output of hello world, we see 30. So that's working. That's great. So let's cover some other data types in C#. So the next data type we'll cover is called float. And the float basically is a decimal point number or just a decimal number. And there are actually different types of decimal data types in C#. But float is the one we'll cover first. So let's define, let's say, a temperature. So we'll say float temperature, and that will be equal to, let's say, 20.4. Now, as you see, as I close this statement out, I'm getting an error message. And the reason why that's happening is because we did not define F at the very end. So I'm just going to put a letter F at the end. And what that tells your computer in .NET is that this number should be treated as a single precision floating point number. What that means is that we're not really so particular, or so we don't really care very much about how accurate the decimal points are, the decimal values are behind or to the right of the decimal point. We just want to have a floating point number that is single precision to the single digit after the decimal point. And generally, the reason why we might want to do that instead of getting more precise with our value is because floats typically run faster than other data types. So if you don't really care much about how precise the number is, you could just simply use a float in most cases. In the case of defining a temperature, I don't think it's a big deal if we just use a single point or a single precision value. So let's output this temperature. So we're going to say console.writeLine, as we have been doing, and we're going to just output temperature. And we'll close that off, and let's run this, and let's see what we get. All right, so as you can see below, we get 20.4, and so it looks like that's working. Okay, so if we want to get a little bit more precise with our decimal value, instead of using a float data type, we can actually use one called double. And double data type gives us double precision or double digit precision, which essentially means it's a little bit more accurate when dealing with longer decimal numbers than float is. So let's say we want to define the interest rate of a loan. Let's create a variable called interest. So we'll say double interest, and we'll set that to 5.53. And close that out. Now, if you notice, I'm getting no error message this time. And the reason why is .NET already understands that this is a standard floating point number. So there's no need to be alarmed there. So I'm just going to simply output this. So I'm going to do console.writeLine. I'm going to show you guys something new. So we don't just need to always output the variables. What we can actually do is we can prepend a string or even append, depending on what you're trying to do, a string to the argument value of this write line method. So if I want to display additional text, for example, before the actual value, I can prepend a string. So let's call this interest. And I'm just going to throw in there a plus sign and then the variable interest. So if I save that and I rerun it, we'll see that we have interest 5.53. So that's working as expected. That's great. All right, so now let's say we want to go even finer than that. We want to fine tune this decimal value as much as possible. So if you ever work in a bank in the future as a .NET developer, you may want to use this particular data type because it's going to be the most accurate precision that you can get from any decimal number. So a great use case for this is working at an investment bank, for example, or any bank where you need to be fine-tuned to the decimal point. And the name of this data type is actually called decimal. So let's define a decimal value. Let's say stock price. We want to define the price of the current price of a stock. So I'm going to write this out as stock price. And notice that this variable, I'm actually writing this in camel case. So again, just to kind of reiterate and just to clarify an earlier point that I made, C# functions are written in Pascal case and variables are written in camel case. So basically camel case is when the first letter of the variable name is in lowercase and then any following word, the very first letter of that following word is written in a capitalized case. Whereas with Pascal case, the functions are all written in capital letters when it's the very first letter of a word. So in this case, I'm using camel case to define this variable, stock price. And I'm going to set this stock price to, let's say, 4 dot, and we just throw in a bunch of numbers here and close this off. Now, if you guys notice, I'm still getting an error message here. There's a squiggly line here under the value. And that's because just like the float number, I have to specify to .NET that this value is a particular or special floating point number. So to do that for decimal, I would specify a capital M. And the way to remember this is for decimals, M stands for, let's say, money. Okay, just for you guys to remember that as a mnemonic device. So now I'm going to output this and see what we get. So console.writeLine, sorry, something happened there. Console.writeLine. And let's say we're going to output the stock price. Stock price. All right, let's see what we get. So if I save that and I run, so we're getting our first error message here. Console does not contain a definition for write. So I'm misspelling something here. Okay, let's fix that. I know what it is. So write line. That should work. So if I run this, now you'll see that I'm outputting the stock price to the T. So it's a very precise decimal value. Now you may be asking, well, why would I use float or double when I could just use decimal? There are some performance differences, especially when you're dealing with larger applications between the three. So I would definitely suggest that you use float or double when you don't really care about having the very precise value. Whereas I would use decimal if I'm working with money. That's the best way to think of it. Money or anything else that's very sensitive to any decimal being off by, a tenth, a hundredth, a thousandth, and so on. So that's the best way to remember it. All right, so let's move a little bit away from numbers for now, and let's move on to other data types in C#. So let's say if we want to define a character. So a character can be any, if you look at your keyboard, you see basically various types of letters and numbers and even special characters. So in C# we can actually assign one of these as a value to a variable by specifying the char keyword. And the char keyword basically signifies that any value stored in this variable will just be a single character. So I guess we can assign a letter grade as if we're back in school. So we'll say char grade, and let's just say that we were good students, so you got an A. So as you see here, we define just a single character, so I can output this, and I'm just going to do a simple output here of console.writeLine, and let's just say grade. So let's run this in our console, let's see what we get, and as you can see, we're good students because we got the letter A. That's great. And something to keep in mind, when you define a char or a character, notice the difference between that and a string. In the case up here, we define a string with double quotes, whereas a char is defined with a single quote or a set of single quotes. So that's something to keep in mind. Remember, if you use double quotes instead of the single, you're actually defining a string, which is actually the next data type I'd like to cover. Now, this is a very common one you'll be using across many applications. So to define a string of text, we just specified the string data type. So let's define a name. So let's say string name is equal to Ron, which is my name. And we close that off, and notice that we have these double quotes, as I said before. Now, when you use a string, you can actually define a string that just has a single character within it, but .NET will not recognize that as a character. It would actually recognize that as a string. So keep that in mind. So I'm going to just set that back to Ron, and I'm going to output something interesting here. So console.writeLine. And what I'm going to do is I'm going to introduce myself. So to do this, I'm going to use placeholders within the string to format some text. So to do that, I'll type it out and I'll show you guys what I mean. So to do that, within the WriteLine method, I'm going to use a $sign and double quotes. And I'm going to say, my name is, and then I'm going to use the curly braces within here, and I'm going to give it that name value and a period, and then close that off. So what I just defined is a formatted string, and I'm basically inserting the value of name within the string literal of my name is whatever. So let's see if this is working now. I'm going to go ahead and run this. And as you can see, it says my name is Ron. So this is another way to output string data. You can actually use this placeholder method or this placeholder approach to outputting variable values within a string literal. So I hope that makes sense to you. All right. So we've tackled characters and strings. Let's move on to something a little bit different here. Another data type is, what if in our application we want to be able to say whether something is true or false? Well, to do that, we can define a Boolean. So to use a Boolean, there is a reserved keyword called bool in .NET. And let's say, for example, we want to, let's say, define whether someone is a student of a school or not. So I'm going to say bool is student, and I'm going to set that to true. Okay? So this is basically saying that this particular user is a student, for example. This console.writeLine, and let's see what happens when I output is student. So if I run this, as you can see below, it outputs true because I defined true, or I set that as the value of is student. Now do notice how this value down here has a capital T as true. Now keep that in mind, that if you're outputting Booleans like this, is going to capitalize the very first letter. So if it were false, it would be false with a capital F instead. So just keep that in mind in the case if you're trying to convert a Boolean to string and you're trying to, check for a particular value, you'll have to take into consideration the casing as well. All right, so hopefully that all makes sense to you. I'm going to work a little bit harder in showing you here exactly what variables can do and the true power of variables. So let's say, for example, we want to just define or declare a variable without assigning a value up front. We can absolutely do that like this. So let's say we want to define the quantity of products in inventory. So we can actually just say int quantity, and we don't have to assign a value up front. We can just define that somewhere in the file. And let's just say we want to define a product. So we could say string data type and product. Obviously, we're saying string because the product will have a name, and the name is of a string data type. Now, in order to assign values to these variables, right below it or somewhere further down in the application within the same method call, or rather within the scope of the method, we can actually set the value. So let's say set quantity is equal to 5, for example, and let's set product is equal to bananas. Hopefully I spelled that. Something happened here. Let's try that again. Bananas. Great. All right, so now let's output that. So let's try that. Console.write line. And by the way, if you guys haven't noticed, there is a write method also to the console. Basically, the difference between write and write line is that write will output the data or the information to the console without a new line break between lines, whereas write line actually adds or skips to the new line. And I'm using write line to make things a lot easier to read in the console. So let's see here. What we want to do is let's just output here the way that we did above with the $sign and the double quotes. Let's output the quantity of the product. So let's say product as a string, and in here we're going to use curly braces and we're going to say product, and then we're going to do a comma and say quantity, and then curly braces again and quantity. All right, and let's run that. And as you see below, we're outputting product bananas and quantity is 5. So that's working as well. So that's basically how we can concatenate values to a string literal, as well as, you know, just declare a variable and assign the values later on. Pretty simple stuff. There is another data type that's commonly used in the .NET world, and it's called constants. So let's go down here and define what a constant is. Let's say, for example, we have a value within the application that will never change. We never expect it to change, and we want it to be read-only anyway. So for a common example, let's say that we're using a mathematical equation and we want to define pi. So we would specify the const keyword, and then if you guys remember back from math class, you have the concept of pi. What happened there? You have the concept of pi, P-I. It's not letting me do it. Let's just do it like this. Pi. And pi, we're going to set that to 3.14. Now, obviously, it's a lot longer than that, but, you know, we'll just make it nice and simple. I'm just going to change this back to a capital P. I'm not sure why my autocomplete was acting up there, but we're going to set that to 3.14. Now, the reason why I'm using const here is, let's say I don't want this value to change. So I don't want someone to do something like this. I don't want them, here we go again. I don't want someone to then come and say, well, pi should really be equal to 2. So if they try to do that, you see we're getting an error message here. And basically it's saying that this is not allowed to be changed because it's a read-only value. So we generally would use this const data type to do that, to protect the value and make sure that no user is allowed to change it. So let's just output this just to make sure that we've assigned this properly. We're going to just say console.write line, and we're just going to output pi. And hopefully that works. I'm not sure what I'm getting an error message for. Let's see. Identifier expects. Okay, identifier expected. I'm so silly. One thing I forgot to specify here is the type. So we still have to specify a type here. We have const double in this case because it's a floating point number. And guys, again, just kind of going back to what I said, this is the reason why, you know, me personally, making mistakes makes me better. And hopefully it's going to make you guys better because you guys hopefully were able to catch that. But, you know, we define const as sort of a final value. One that will not change, and we still have to specify the data type. So const is sort of like a special data type on top of a data type, if you will. So now it looks like the error messages are gone. If I were to rerun this, now you see we see 3.14 in the console, and basically we were not allowed to change the value. So that's generally how that works. And yeah, that's pretty much variables and data types, and we're going to get a lot deeper into this as we go along. All right, so now that we understand variables and data types, let's move on to math operators. So basically, math operators allow us to calculate mathematical equations and, you know, calculate by adding, dividing, multiplying, and subtracting. And we can do many other things with mathematical operators as well. And this is basically an easy way for us to calculate values within our program. So what I'm going to do here is I'm going to come back up here to the top to our main method. And within our main method, I'm going to define a new method right here. So I'm going to call this method math operators. close that out. And again, we don't have this method yet. That's why we have this error. So I'm just going to copy its name. I'm going to go right back down here. I'm going to define a new static void method. And it's again void because we don't need to return anything. And we're going to call that math operators. Okay. So what we want to do is we want to be able to cover all of the major mathematical operations that exist. So that you'll be able to work easily with numbers within these programs. So the very first thing we'll do here is let's define a couple of numbers here. So let's define a num1 variable. And in num1, we're going to set that to 10. Then let's define a second number variable, and we'll set that to 5. And in here, what we want to do is we want to first do the addition. So I guess we can create another variable called addition. And we're going to set that addition to num1 plus num2. And semicolon. And let's just output that and see what we get. So console, console, is spelling that, dot right line. And we're just going to output the addition value. So when I save that and I run it, as you see below, it's taking a while, sorry. There we go, 15. So we get the value of 15 because we're adding 10 and 5 together. So that's addition, it's that simple. So what I would say, guys, is as we go through these examples, feel free to stop the video and try it yourself before we continue. So that way you can kind of figure things out on your own and learn how to problem solve. So the very second thing we'll define here is we're going to subtract numbers. So let's do that. Let's say int subtraction is equal to, and we'll make it nice and simple, num1 minus num2. So with that being said, guys, what is the answer going to be here? So pause the video if you want to and give it a shot yourself. Okay, so now we're subtracting num1 and num2. So let's just output what that is. So we're just going to output here subtraction, and we're going to run this. And you see that the value is 5. Now, I want to show something. What if, for example, we said that num1 is 5 and num2 is 10? So now we're subtracting 10 from 5. So if I rerun this, you're going to see that the output now is -5, making this integer signed because it represents a negative value. So just keep that in mind. We're also able to get negative values as well. So I'm just going to set that back to 10 and 5 to make things simple so you guys can follow along more easily. Cool. So now the next operation we want to show is multiplication, of course. So multiplication. I hope I spelled that correctly. Multiplication. Yep. So we're going to say num1, and to multiply, we need to just the asterisk key. So num1, num2, like that. And let's just output that as console.writeLine. And we're just going to do multiplication. Save that and run. So now we're expecting 50 and we got it. Okay, so 10 times 5 is 50. And lastly, we're going to do division. So let's do int division is equal to num1. And to represent dividing or division, we're just going to use a / num2. And let's just output that console writeLine division. And let's run this and see what we get. So we get 2. Now, what happens, and kind of going back to the example I had before, what happens, let's say, if this were 5 and this were 10? Let's see what would happen in the case of division. So I'm going to run this. And as you guys see, the answer is 0. If you guys remember back to grade school math or high school math even, you know, when you divide by this number, you're basically going to get 0 in this case, right? But there is a way for us to represent remainders in C#. So I'm going to do that right now. But just keep in mind when you divide a number like that, that basically if you divide 5 into 10, or rather 10 into 5, you're going to get 0, because obviously you're dividing the bigger number from the smaller number. So just keep that in mind, guys. There's also something called the divide by zero exception, or it's an error called divide by zero. That's something you have to look out for when you're writing code, and you need to handle that situation properly. So that normally happens, for instance, if you're dividing 10 by 0. Basically, if you don't handle that error properly, it'll stop the execution of your program, which is not a good thing, especially if you're running in a live environment. I'm going to show you guys later how to handle that particular case once we get to exception handling. So far I've shown you guys how to add, multiply, divide, and subtract. But one thing I want to also show you guys is basically how to get the remainder from a division. So for example, let's say we want to divide 11 into 5, but we don't want to, or rather 5 into 11, but we don't really care about what the quotient is. We care about what the remainder is. So there is something called modulus. So I'm going to define int modulus, and that's going to be equal to num. Let's change these numbers. Let's define some new numbers here, or actually we'll just write it in line. Let's just say 11, and to represent modulus, you use a percentage sign, and let's just use 5. So what do you guys think this result is going to be? Let's output it and see what we get. So we do console.writeLine, and we'll say modulus. So let's run that. And as you guys see below, the output is 1. Why is that? Well, that's because if you divided 5 into 11, you're left with a remainder of 1, because 5 goes into 10 2 times, and then you have 1 to carry over. So that's the reason why. So you generally would use modulus for things like if you want to figure out odd numbers versus even numbers. You want to find out how much is left over after a certain division operation has been run, and so on. So there's many different use cases, and it's a very helpful thing to use. So moving along here, let's look a little bit more into various other things that we can do with operations. Now, as I mentioned before, there is the divide by zero scenario that could occur. So let's define that. Let's say we have another number value. Let's set that to 5. And then we have a fourth number value here, and we'll set that to 0. Now, we have a scenario in most programming languages where if you were to do the actual math, like 5 divided by 0, it's going to throw an error message or an exception. And generally, an exception is an error. If you think of those two things synonymously, then basically that's what it is. So to handle that scenario, there's something in programming, but specifically here in C# called the try-catch block. And basically the try-catch block allows us to gracefully handle an exception or an error message, and avoid stopping the program, or avoid the program just failing execution. So I'll show you guys exactly how that works right now. So I'm going to first define the try block here. So within here, I want to just kind of demonstrate the exception itself. So let's say here int division, or let's use something here. Let's say int quotient, something else. That's going to be equal to num3 divided by num4. Okay? Now normally this line alone should cause the exception. But just to be certain, I'm just going to console.writeLine here, just to be certain that we are basically jumping to the next block of code on failure. So I'm going to specify here the quotient, just output that to the console if it works. So in the case of this line not working, then we need to be able to catch this exception. So to do that, we need to just specify the catch keyword and add some parentheses here. And the specific error message or exception type we're looking for is called divide by zero exception. And then we specify a variable after that of EX, which normally stands for exception by convention. So now we're basically saying, in the event that an error happens within the try block above, catch that exception and attempt to handle it gracefully. So that way your program doesn't just crash. It'll continue running, but you may be able to output this error message to, let's say, a log or a database file or whatever we're going to output it and save it for, or save it to rather. So let's just output something here just to make sure that this is working. So I'm going to do console.writeLine, and in here I'm just going to put a string literal of an error occurred. And in here, I'm going to say EX, which is the exception object or variable. And there is a property on it called message. So we'll say .message. And this is a built-in property as part of the .NET exception base class, which basically allows us to output the actual error message to the console or to the UI, wherever we're outputting our data. So with that being said, I should be able to run this and I should see an error message. So let's give that a shot. Let's run this. And there we go. We see an error occurred and basically attempted to divide by 0. So whenever you get this exception message, basically this is a way to handle the exception gracefully, so that way your program just doesn't crash. It'll continue running and you'll probably have like a log on the back end that will be able to capture this error message, and then you and your team can look at it and figure out the best way to remediate it or to triage it in that way. So yeah, that's basically how that works. All right, so now that I've shown you that, I guess the only other thing that's remaining here is to pretty much say that whenever you're working with number types, you can actually cast or convert specific numbers to other number types. So for example, let's say, I guess the best way to show you is with an example. Let me just make sure that everything's good there. Cool. So let's say I want to convert an integer to a double. You can absolutely do that. Let's define an int of num5, for example. Let's just say 100. Or let's make it simple, different, 105. I can actually cast this to a double, and I'll show you guys how right now. So let's say double, and I'm going to just say num5 as double, just to let you guys know that this is the double version of that. And to cast this, it's simple. We're just going to put parentheses, and we're going to say the double data type, and we're going to then say num5. And now let's try to output this and see if it works. So console.writeLine num5 as double. And save that. And if I run this, you'll see that it says 105. Now you don't see any decimal places because of the fact that there were no decimal points at all. But generally it is a double, and you can take my word for it that it is now casted to a double. So you may, a common use case for that is, for example, if you're working with an integer and you want to be able to do some clean mathematics between another double value and this double value, you might want to convert this first to a double and then multiply, divide, subtract against the other double value. So that's like a common scenario. You can also go the other way around, but there are some things you have to be cautious of whenever you're casting number values. You want to make sure you don't lose data as a result. So I would definitely recommend going online and looking at the .NET documentation, just making sure you understand more about typecasting, specifically typecasting numbers. So that's it for math operators. The very next thing we're going to tackle here is comparison operators. So let's go right back up to the top as we had done before. And as you guys may have guessed, we're going to define a new variable, or rather a new function call. So we're going to define a new method here called comparison operators. My typing today is bad. But comparison operators, and let's copy that name here to save us the trouble. And we're going to scroll right back down to the bottom of this file here, and we're going to say static void comparison operators and just open that up. Now, what is a comparison operator? Well, basically comparison operators allow us to compare values to one another, and we're using these comparison operators usually to specify conditions within an application. If we want a certain set of instructions to be executed based on a given condition, we would use comparison operators in conjunction with control flow statements such as if and else statements to control the logic, the actual logic of the application. So let's start off here by first declaring a couple of variables. So I want to declare a couple of integer variables. So let's say int a is equal to 10 and int b is equal to 5 to keep things simple. Okay, And the reason why I'm defining these is because I'm going to be using these within our comparison operations to show you guys exactly how this works. So the very next thing I'll do here is let's declare a Boolean. And that Boolean we'll say is equal. So we want to find out if these two numbers are equal. So to do that, let's open up some parentheses and say it's equal if A is equal to B. Okay? So just to let you guys know what this is a comparison operator. This double equal sign represents equality. If you notice to the left of that, we have the single equal sign. So the difference between the two is a single equal sign specifies assignment. So when you're assigning a value to a variable, for instance, double equal specifies equality. So you want to use double equal signs if you want to compare two numbers or two strings to each other or two objects in some cases and so on. So let's just output this and let's see if 10 is equal to 5. And I think that if you guys are good at math, you already know the answer to this. So we're going to output the Boolean value of is equal. So obviously this will either be a true or a false value. So let's run this. And as you guys see, the very last output, it's false. So 10 is not equal to 5. That's exactly what we expected. But now let's go the other way with it. Let's say we want to find out if two numbers are not equal. So again, I'm going to define another Boolean and say is not equal. And to check for inequality, what you want to do is you want to use an exclamation mark with a single equal sign like this. So A exclamation not equal to B. And let's console.writeLine that. Console.writeLine is not equal. Now, what do you think the answer to this would be? Let's run it and find out. It's true. Now, why is it true? Because obviously 10 is not equal to 5. So basically we did the inverse of the is equal above. And this is very, very helpful because then if you're not really sure if something is equal or not equal, you can just kind of determine based on the given circumstance which one you should check for. So the next thing we want to do is, obviously, you probably guessed it, we want to find out if 10 is greater than 5. So we're going to say bool is greater, and we're going to say A is greater than B. Now, greater is specified, as you know it from school times, is specified by a right angle bracket. So let's go ahead and output that. Console.writeLine is greater. And let's run that. And as you can see, it's true because 10 is greater than 5. Let's go the other way around. Let's check for less than. So bool is less. And we're going to say if A is less than B. And obviously we're expecting false here because 10 is not less than 5. Console.write, something's wrong here. So let's just write a line. It is less. All right, so let's output that. What happened here? Here we go. Let's output that. And as you can see, it's false because 10 is not less than 5. So it's pretty simple. You just got to kind of think of math, your math classes back in the day, and you could pretty much figure out what to do here. But we've got more. So let's say if we want to find out if a number is greater than or equal to another. Now, as you can see above, we've already specified greater than, but let's do is greater than or equal. And to do that, we're going to say A, if A is greater than or equal to B. So basically a greater than sign followed by a single equal sign. And so let's output that by console.writeLine. And then we're going to say is greater than or equal. And let's output that. And that output's true because 10 is greater than 5. Okay? It's still greater than 5. It's not equal to 5, but it's still greater than 5. So now we're going to go the other way around with it. We're going to say if then 10 is less than or equal to 5. Less than or equal, parentheses, A is less than or equal to B. Let's do console.writeLine. And is less than or equal to, and semicolon. Let's run that. And that's false because 10 is not less than 5, and 10 is also not equal to 5. So basically all of this is working, and I will say there's really no reason for you to have to write unit tests for simple equations like this, because your computer is rather smart when it comes to mathematics. So yeah, this is definitely how you use math or arithmetic operators within an application. All right, so next up is logical operators. So basically we can use arithmetic operators together with comparison operators and logical operators to write some pretty advanced code or advanced logic within our application to have it do some pretty cool things. So what I'm going to do next is I'm going to scroll right back up to our main method again. And in our main method, I'm going to write another method call called logical operators and close that out. And then I'm going to copy the name again. Let's make sure it's copied. Let's go down to the very bottom of the file and let's specify or create a new method called logical operators. So basically with logical operators, there are many of them that can be used to specify whether we want to check for two or more conditions to be true or false, or if we only want one of them to be true or false. And I'll show you guys exactly what I mean with that. So basically what I want to do here is I want to be able to specify whether two operands are true together or if only one of them is true. And I'll kind of explain more about it as I go along here. But let's just start off by defining some variables. So let's say that the first variable is a Boolean data type, and we'll call it X, and we'll set that to true. And then we'll create another one called Y and set that to false. And this is going to be the best way to help you guys understand exactly what I mean. So we would use, for example, if we want to check that two operators are creating a condition that is equal to true, we would use the AND logical operator, and it's written like this. So let's create another variable called AND result, and that is going to be equal to X and Y. So basically what this is saying is if X is equal to true and Y is equal to true, then the entire condition is true. And as you can see, this is how you can start to build some very complex logic. So let's console.writeLine this. Can you guess what the result is going to be in this case? So let's go ahead and run this. And as you can see, we get a result of false. Now, why is it false? Well, going back up here to where we declared and initialize these variables, X is equal to true and Y is equal to false. But down here, we're saying we're betting on basically X being true and Y being true. But in this case, because Y is false, then that means that the entire condition is now rendering to false because X is true, but Y is false. I hope that makes sense. So basically, both conditions must equal true, not necessarily true the value, but they must pretty much evaluate to true in order for the entire result to be true. So let's do this with another example. Let's create a situation where only one of them needs to be true. So we're going to call this bool or result. And we're going to say if X or Y, and or is represented by a double pipe character. So if X or Y, then it's basically going to evaluate to either true or false. So let's console.writeLine this. We're going to output or result. Now, based on this, we expect to get back a true, and the reason why we did get back true is because X is equal to true. Y is equal to false. So what happened here? Let me explain why this works. As I said before, this logical operator is a double pipe which symbolizes or. An or condition, either this or that is true. In this case, X was the very first thing that was encountered here or that was executed, which evaluated to true. There's a concept called short-circuiting, and basically in computer programming, a short-circuited language like C# will stop evaluating a condition as soon as they find the very first condition in the evaluation that's true. So in this case, X is true, so then the code stopped pretty much evaluating this entire statement once it found that X was true. If Y were first and then X were second, then Y, obviously with it being false, this would evaluate to false. So then it would run X as the second parameter and check if X is true. And then in that case, the entire statement would evaluate to true in that case. So either way, it would be true. It's just a matter of which one is being put first, and if we're short circuiting, out of this evaluation. So hopefully that makes sense. You might want to read up on that online if it doesn't, or maybe just kind of rewatch this several times until it does make sense. Let's move on. So let's say that we want to negate a circumstance. I'm going to give you two scenarios here so you can hopefully understand a little bit more about the AND result part as well. But if you want to check for the exact opposite, we can use a not operator, which is just an exclamation mark. So let's go ahead and define bool and call this not result 1. And we're going to set this to basically what we see above with the AND result, if X and Y. But instead, this time we're going to say if X and not Y. And the reason why we're doing that is because of this. We want this to evaluate to true in this case, just as an example. So we already know that X is true and Y is false as said above. But because I'm specifying this exclamation mark in front of the Y, then we're basically saying if not false, which is basically true. So now with that being specified, we're basically expecting this to evaluate to true. So let's output this as console.writeLine, and we're going to say not result 1. And let's run this. And as you can see, it evaluated to true. And the reason why, again, is because X is true. And in this situation, Y is normally false. But because we're putting this exclamation mark in front of it, we're basically inverting it to true. So true and true is equal to true. So that's basically how that works. Let me give you another scenario. Let's say, for example, I want to just invert X on its own. And as we already know, X is currently true. So now I can say bool not result 2 is equal to not X. So we're basically just inverting X. So the inversion of a true value is a false value. So that's what we're expecting to see. So if I console.writeLine this, and I just say not result 2, what do we get? Let's run that. And basically we get false because the inversion or the opposite of a true is a false. And being that X is true, the opposite of true is false. So X is now false, or not result 2 rather is false. So that's basically logical, the first set of logical operators that you definitely need to know more about. And, again, you would use this generally together with other logic such as flow statements or control flows like if, else, which we'll get to in a little bit. You use this together in conjunction to be able to evaluate or set conditions and so forth. So that pretty much sums up logical operators. It's pretty straightforward. You might want to read the documentation to get a little bit more understanding of exactly how that works in tandem with other types of operators and control flow statements. So let's just kind of keep moving on because we still have quite a bit to cover here. So I'm going to cover next conditionals. And again, this kind of works in tandem with logical operators as well as math operators and comparison operators. You don't necessarily have to use all of them together, but there are many scenarios where you would use kind of like a mix of all of them or just a couple at a time and so forth. But conditional operators, or rather conditional statements, are very, very important in programming because they allow us to define certain pathways within our logic. So let's go ahead by creating a new method call here called conditional, we'll call it conditional statements. Cool. I'm just going to go ahead and I'm going to copy this, and I'm going to go down below all the way to the bottom. So you see this code is starting to stack up, and we're going to define static, void, and conditional statements. Now in a conditional statement, what we generally mean by that is there are many different conditional keywords in the .NET programming languages. And in fact, a good bonus here is that many of these are also used in other programming languages. So once you learn it here, you pretty much know it for majority of the C, programming language derivative languages out there. And so we're going to start off with the if statement or the if else statement. And basically what that is we're basically going to say if a condition is true, do an action, otherwise do something else. So the best way to show this is by an example. So I'm going to first off define a new integer variable called age, and I'm going to set that to 25. And then next, I'm going to define this if statement. And so we do that by just saying if, and within this parenthesis, we just specify the age variable. And then we can use something like a comparison operator to compare this age to another value. So for example, we could say something like if age is greater than 18, so actually, you know what? Let's go this way with it. Let's say if age is less than 18, then we want to say something. So let's say, for example, if this person is under the age of 18, we're going to say you are a minor, right? Now, usually when we have an if, we could just have this if block by itself. But even more commonly seen is when you normally have an if, you would have an else. But just to kind of demonstrate what this is, I'm going to just run this, and I want you guys to kind of guess what might happen here. So I'm just going to run this with just the if statement or the if block. And as I run this, you guys can see that nothing happened. Okay, and nothing happened because age is equal to 25, and 25 is not less than 18. But if I were to change this age to, let's just say 5 years old, and I run this again, now you'll see that you are a minor. So that basically evaluated to true. Once it got to this line, it said, okay, what's the current age? Your current age is 5, and 5 is less than 18, so you are a minor, gets outputted to the console. So I'm just going to set this back to 25, or yeah, 25. And let's move on. So that's if. But as I said before, more commonly with if, you would also see else. So now let's define an otherwise scenario. So if this is not true, then do something else. So let's say if the person is not a minor, we can just console.writeLine, you are an adult. Nice and simple. All right. So if I run this, we expect to see you're an adult, and we do. And the reason why, again, is because 25 is greater than 18. And because this statement evaluated to false, in this case, this age is less than 18, that's the reason why we're hitting this block down here and we're getting this output. Now, to make things a bit more complicated but powerful, there's something called the else if block as well. And the else if block allows us to chain multiple if statements together. So here's an example. In this case, let's say, for example, we want to specify if the person is between 18 and 65 years old. So in that case, let's just do something like this. First of all, I'm just going to come down here, and I'm going to just remove this output statement from here for now. And I'm just going to come up here to right here. Oops, why is my cursor not working here? Okay. So I'm just going to put my block here on line 140, and I'm going to say else if, and I'm going to define another else if here. And just open up that so we don't get confused. All right, so basically in this else if, I want to say if this user is between the age of 18 and 65, then they are an adult. So let's say age is greater than or equal to 18, and here's where we can use the logical operator of double and sign. So we're going to say double and sign, and we can say age is less than or equal to 65 years old. So if that's the case, if this is true, and this just pastes in what we had before, you are an adult. So basically your working age, you're between 18, starting at 18, so greater than or equal to 18, and less than or equal to 65. Otherwise, if that is false, in this else block, we're now going to say console.writeLine, you are a senior citizen. All right. Nothing wrong with senior citizens, by the way, folks. All right, so now let's see what we get. So again, age is 25. So what do we expect this output to be? Let's run this. And we see still that you are an adult. And again, if I were to change this age to below 18, let's even say 17, and run this, we're going to see you're a minor. If I change this age to 18, right on the bound there, let's run this again, we see you are an adult. If I change this age to, let's say, 100, congratulations. We see here you are a senior citizen, so this is working. So again, with a chain of if and else statements, we can actually chain together different logical flows within an application. This is very powerful, and being that you learned it here, it's more than likely going to apply to most C derivative languages. So like languages like JavaScript and Java and even Python, even though it's using different keywords, you can still literally use the same concepts in all of these programming languages. Once you learn it once, you'll never forget it. That's the good thing about it. All right, so let's move on to something else here. And for this one, I'm just going to copy some code that I have written somewhere else because it's rather lengthy. So just bear with me for a second here. Let's just grab this. And basically what we're going to talk about right now are switch statements. So what a switch statement is similar to an else if statement, but a switch statement allows you, kind of like in a tree-like structure, to define different logical flows within one single block of code. So to show how that works, I'm just going to paste this code in here nicely and quickly here and kind of walk you guys through it because it's quite a bit. So what I did first up here is I defined a day variable and I set that to 3. So that kind of represents the day of the week, the third day of the week, if you will. Then I have here a string data type variable called day name. So the name of the day of the week, Monday, Tuesday, Wednesday, and so on. So here I define a switch statement. And again, a switch statement, think of it almost like an if and else if statement. But essentially it's just one code block, and it allows you to logically list out various conditions that exist and then run actions based on those conditions, evaluating to true. So here we have this day variable that I specified that I'm passing in, and basically what this switch statement will do, it will check each case to see if day is equal to a specific value. So as you can see here in this code block, in case number 1, it's looking to see if day is equal to 1. Because we specified day is equal to 3, then we would expect that this case 3 would run and it would output Wednesday as the result. Now you may be asking yourself, what is this break keyword within each and every sort of branch? Well, the break specifies what must happen. Like basically we're exiting this branch of code if a condition is true. And the reason why we do that is we want to short circuit, again, going back to that term, we want to short circuit execution of a certain branch if the condition has been evaluated to true. So in this case of case 3, because day is equal to 3, it's going to go to this code block and day name is going to get set to Wednesday. And then we're just going to break out of this entire switch statement and it's just going to exit. So let's try to run this and see if we get this output below. So if I run this, okay, I see an error message, type of namespace definition. Okay, so we're having an issue here, and I think it's because we have this extra bracket on line 176. So I'm just going to get rid of that and save and run it. Okay, and as you see here, we have today is Wednesday. And again, the reason why we get Wednesday is because day is equal to 3, and being that we're passing that day value into our switch statement as an argument is basically evaluating this case to true, and it's assigning that Wednesday string literal to day name and short-circuiting out of the execution. So that's basically what's happening. If I were to change this to 1, then we would expect a different output, and that would be Monday. So I did that, and now you see that today is Monday. So this is working. So now why would you use a switch statement instead of an if, an else block? Well, generally, if you're going to have a lot of different branches of logic within a single method, you might want to use a switch statement if applicable, because it's going to save you a lot of code lines, right? You'll write a lot less code to do the same thing. It's also a lot easier to read depending on exactly what you're writing. So I would just say you just need to use your best judgment whether an if else if makes more sense or whether it makes sense to do a switch statement. I personally prefer to use switch statements if I'm writing more than 3 branches of logic. So if, for example, if I have a condition that can have more than 3 possible logical routes, then I would use a switch statement in that case, because it would be a lot easier to read and a lot easier to change in the future. However, if I have like 3 or less, I generally go with an if else if, only because there are some programming languages that don't have the switch case statement. So just keep that in mind. So that's pretty much how logical operators work. So now let's move on to loops. And what loops are, they're basically structures that allow us to iterate through various collections. And what that means is, instead of writing code repetitiously over and over again, in some cases we can use loops to save us some time and write less lines of code, because a lot of the information would be the same, or would be pretty similar, or even a lot of the logic would be similar. So that's the reason why we would use loops. So let me just kind of demonstrate you how that works. I'm going to go right back up here to the top, and in our main method here, I'm going to define another signature here, sorry. So we are going to call this just loops and close this out, and then we're going to come to the bottom here of loops, and we're going to, or rather of the prior method, and define a loops method like that. Okay, so I think the best way to demonstrate this is kind of working with various data types and kind of show you exactly how this would work. So let's see. Let's say, for example, we want to iterate from 0 to 5, and we just want to output the numbers to the console. We want to show each number outputted in repetition, or in iteration. So to do that, there's something called a for loop, and we would write it like this. We say for. The next part is within the parentheses, we specify the data type, which we more than likely 9 times out of 10 be integer. And then we give it a temp variable, or a temporary variable. This variable would serve as a counter that serves its purpose of sort of keeping track of the iteration within the loop. So we're going to call this int I is equal to 0 to be the starting value of 0. Then a semicolon. The next thing within this loop we're going to specify is the condition at which the loop should end. So we're going to say if I is less than 5, or actually, you know what, let's do if I is less than or equal to 5. And what we expect this loop to do now is we expect it to iterate from 0 to 5. So 0, 1, 2, 3, 4, 5. Lastly, as a condition here, we specify something called an increment operator. Now, the increment operator is specified with a double plus sign, and what that is basically doing is taking the value of I on the first iteration. For example, in the first, I will be equal to 0, and it's incrementing that count by 1 on the next iteration. So then on the next iteration, I will equal 1 because because 0 plus 1 is equal to 1. Then on the following iteration, it will equal 2 because 1 plus 1 is equal to 2. So if you want to increment, instead of saying I is equal to I plus 1, you can actually say I is equal to double plus, or I double plus, and that would increment the value. On the other side of things, if you want to decrement, you could say I double minus, and that would reduce the count by 1. So let's go ahead and close that up here. And within this block, all we want to do is something simple. We want to console.writeLine the output of the number. And to do that, just to kind of make sure that we're outputting the correct thing, I'm going to put a string literal in here, and I'm going to say number is equal to, or not equal to, but number is of I. So we're just outputting the value of I in this case. So if I run this, it's taking a while. There we go. So we see that it's outputting 0 through 5. On each iteration of the loop will basically, what will happen is once it hits this for loop on line 180, is all it's going to do is check the condition. It will initialize the variable to 0. It will check if 0 is less than or equal to 5. And then on the next iteration of the loop, after the console.writeLine is outputted, it will increase the counter to 1. and then 2, then 3 subsequently. So that's basically how a loop works. A for loop specifically works in C#. Now, the good thing again is that this knowledge is transferable. You can actually use a similar structure in other programming languages. So again, you learning it here is applicable to many programming languages. Now, the next thing we have here is the while loop. And a while loop is generally used when you're not really sure about how long a loop should run, but you want to specify a condition that needs to be met for the loop to exit. So basically how that works, I'll give you a simple example here. Let's say if I define a counter variable, or let's just say int count is equal to 0. Okay? So int count is equal to 0. And the reason why we want to specify this integer variable is we want to avoid a circumstance called infinite looping. And basically what that is when you have a while loop and you don't have a counter somewhat getting incremented or decremented within the while loop, it could be that while loop will run infinitely. And when that happens, it can lead to a stack overflow exception in some programming languages, or a memory leak. So generally what you want to do is you want to specify this count variable or a counter variable to avoid that circumstance from happening. And let me demonstrate. So next we're going to define our while loop. So we say while, and we're going to say while the count is less than 5. So something similar to above, but we're just going to say less instead of less than or equal to. So while this count is less than 5, let's just output here console.writeLine. What we're going to output is, let's just call this a string literal of while count, and we're just going to output here the count. And if I were to run this just like this, we're going to have the infinite loop scenario because we're not incrementing or decrementing 5. So in this case, we're not incrementing it so that this condition here, this count is less than 5, will ever evaluate to false. Because what needs to happen is this needs to evaluate to false in order for the program to exit this while loop. While this condition is true, it's going to continue to iterate and loop through this set of instructions. So what we generally want to do here is below this, we want to say count plus plus. So that way we increment this count as we go along, and eventually this count will hit 5. And once it does that, then this program will exit this while loop. So let's go ahead and run this and see what we get. So as you can see, now that we ran this, we don't see 0 to 1 million or any large number. We actually see 0 through 4. And the reason why is because the loop exited as soon as count equaled 5, because the statement evaluated to false in that case. So that's basically how you use a while loop. Again, we would use this instead of a for loop if we're not really sure in advance how long we want something to loop. We just want it to loop, and we may specify this count variable. You don't necessarily need to use the counter in this section here. You can actually use any other kind of like Boolean evaluation or Boolean variable here. You just got to make sure you have a counter set, and that somehow whatever you set, that needs to be sort of like included in this evaluation so that this will eventually exit the loop and avoid an infinite looping scenario. So the next type of loop we're going to cover here is the do-while loop. And basically the difference between a do-while and a while loop is that a do-while loop is guaranteed to execute at least once, whereas a while loop does not have that guarantee that it will execute at all, especially if the evaluation of the statement is false. So in this case, let me just demonstrate. So let's say, for example, we'll specify a do-while loop here, and it's written like this. We say do as a keyword, and then at the very end of it, we say while, and we'll use the same counter variable. We'll say if the count is less than 10. And don't forget to put a semicolon. This is actually one of the only loops that actually has a semicolon at the very end of the line. And if you don't do that, you'll get an error message. So make sure that's included. Now, what we want to do here, just before we write the code here within the loop, is we want to be able to reset the value of count to 0. So that way we can clearly see the output. All right. So what we want to do is let's just output console.writeLine. We're going to say do while count, and we're just going to output count. And let's not forget, guys, to also increment our count, because if we don't, we're going to have an infinite loop situation, and then it will be hard to continue running this code. So let's go ahead and run that and see what we get. So after running that, as you can see, sorry, my console skipped somewhere. As you can see here, we actually iterated from 0 to 9, as you can see here. So this is working as expected. Basically what happens is the iteration runs at least once, and then it basically evaluates thereafter this statement here. So it's guaranteed to run this console write line within the do, and then it does the evaluation of count is less than 10. And then what we're doing here is we're incrementing the count by 1 on every single loop, and then until it reaches 10, and once it reaches 10, it exits the loop. So that's a do while. To be honest with you, it's not used as commonly as other types of loops are, but it can come in helpful if you want to guarantee execution of a block of code at least once. So it could definitely come in very handy there. All right, so there's also some other types of loops that we can cover. I'm just trying to think if I should show you the for each. Yeah, you know what? I'll go ahead and show you. We may be jumping the gun here a little bit, but I'm going to show you guys the for each loop. So generally in the what the for each loop is basically a special loop type that iterates through a collection or an array. So an array and a collection are basically sort of, if you think of like a list of various values contained within a box, then you have like various values of the same data type, and usually in most cases. And that's basically what a collection is. It's a collection of values, usually of the same data type, that you can use to store multiple values within that list or within that collection. So arrays can be used in that fashion, as well as list sets. There are multiple types of collections that we'll go through shortly. But what I'm going to do is I'm just going to use a simple array, since it's the simplest type of collection structure, if you will, just to demonstrate how a for each loop works. So what I'm going to do here is I'm going to specify an int array. And we do that by first specifying the data type, which is int, and then we have this opening and closing bracket, square bracket. That signifies that this is going to be a collection of values or an array. So we're going to just create an array of numbers. So we give it the name numbers, and within this array, we can just open up some curly braces and specify the numbers. So 1, 2, 3, let's go all the way to 5. There you go. So now we have an array of 5 numbers within it. Now, one thing I want to point out here, we're going to cover arrays shortly, so I'm not going to go too much in detail, but basically every single position of an integer within this array is called an index. So basically the integer value of 1 is an index of 0. The integer value of 2 is an index of 1. So basically it's a zero-based index, where the first position within an array, a list, or any other type of collection is basically the 0th position. It always starts with 0. So if you want to grab the value of 1, you would specify the index of 0. If you want to grab the last one, you would specify whatever the last position is minus 1. So in this case, we have 5 numbers. It will be the index of 4, not the index of 5. And you have to know that because you want to avoid error messages, especially index out of bounds exceptions. So let's go ahead and kind of demonstrate how this for each loop works. So to loop through and output all of these numbers, I'm going to type the keyword for each with no space in between. And then I'm going to specify here what our conditions are. So within the parentheses, what we want to do, and I'm just going to type this out and I'm going to walk you guys through it. We're going to say int number in numbers and curly braces. So basically what this says here, guys, is that for each iteration of the loop, we want to grab a single number from that index, the value from that index, which is an integer data type, and we want to grab that from the collection or array of numbers. And let me show you how this works with the output. So if we console.writeLine, and we're going to say number in array, for example, and we just output the number. If I can type it, number, yep. And let's run that. Let's see what we get. Cool. So now we see here that what the for each loop is doing is starting with the number 1, which is in the 0th index or the index of 0, and it's outputting every single number until the very end of the list. Now, what is the huge selling point of using a for each rather than just using a simple for loop? Because you could do something like this as well, and I'll just show you guys the difference. You guys could have done something like this. You could say for int I is equal to 0. And then you can say if I is less than numbers dot length, and basically what this dot length property is this is a property that gets the length of an array, so how long the array is. So in this case, it would be 5, right? It would be the length of 5 because there are 5 items in the array. And then you do the I++, and then you could have said console.writeLine. And then you could say using standard, just to kind of differentiate here, for loop, and then say number. And in here, you could have said something like numbers of I. So basically what that's doing is on every iteration of the array, it's going to output using the current value of I, whatever is in that index. So on the first iteration, I is equal to 0, so it's going to get the number that's in the 0th index of the array. And just to make sure that that works, let's run that. And as you can see here, we are getting the same output as we got with the for each. So now, hopefully you guys can see the difference. Basically, looking at this, I would say the for each loop is a lot simpler to understand if I'm a new developer. And also, you don't have to really worry so much about index out of bounds exceptions. So for example, I'll show you guys an example. Let's say, for example, just really quickly, we know that we have 5 items in the array. Let's say if I try to grab the 10th item, or rather the 10th index in the array. If I were to run this now, you guys see that we have a bunch of gibberish here saying unhandled exception, and it's basically an index out of bounds exception. And the reason why is because we don't have 11 items in the array, because I'm grabbing the 10th, which is essentially the 11th item in the array. We don't have 11 items. That's the reason why we're having this issue. So I would say, honestly, it's much safer to use the for each loop instead of using the standard for loop when you're dealing with collections, because then I don't want to say you're guaranteed to not have problems, but you're a lot safer using a for each in this case when you're not sure how long a collection is or how many items are within the collection. Okay, so those were loops, and we also covered a bit of arrays, but I want to go a little deeper into it. And I know I jumped the gun, but I wanted to be able to show you guys how for each loops work and how they work together with collections. So let's go ahead and let's jump into arrays. So what I'm going to do is I'm going to scroll right back up to the top, and I'm going to go back to my main method. And in my main method, I'm going to create a new function call called arrays. Okay. And then I'm going to go right back down here and define a new method called arrays. So let's just spruce this up a little bit and say static void arrays. Okay, so all I'm going to show you here is basically a little bit more about how arrays work. You already know a bit from above when we worked on the for each loop, but let's go ahead let's start by defining a string array. So we'll say string array, and we'll have an array of names. Now above, what I did is I used curly braces to define an array, which is the shorthand way of doing it. But let's say we want to hard code and specify a certain number of indexes within the array or a certain number of positions. We can definitely do that by using the new keyword and say new string, curly braces, and specify the number of positions. I'll say 3 here. So what that means is we are not allowed to define more than 3 positions within this array. If we try to assign a value to, let's say, the 4th position, we're going to get an index out of bounds exception. So let's go ahead and define some names. So the first name, which will be an index of 0, will be Ron. The second name, which will be an index of 1, will be Katie. And the third name, which will be an index of 2, will be Jack. All right. And if we want to know, definitely, I mean, we can simply see that there are 3 items in the array, but let's say we don't know that. If we want to know how many items are in the array at any given point, we can use the .length property on the array class within .NET. So what we say is names.length, and that should give it to us. So I'll go ahead and run this. And as you can see, the length is 3 because we have 3 items in the array. Okay. And again, if we want to, let's just say grab a specific value from the array, let's just say we want to grab the second value, the second item, we just need to simply say names of 1 because we want the second item. So if I run this, you see I get back Katie because she's the second person in the array, or the second name rather in the array. So that's basically how arrays work on the in the easiest way possible that I can explain. Arrays are very, very powerful because you can do many things with them. You can iterate over them. You can hold many different values. You can even have an array of objects, which is a little bit more generic in a sense, but that's generally how arrays work. Now, with that being said, we also have other data structures within C# that work similarly to arrays. We have ones called collections. So let's scroll right back up to the top and let's demonstrate how collections work by defining a new method called collections. And back to the bottom we go. And down here, we're just going to define a new static method, static void collections. So in general, in a nutshell, what a collection is, it works similar to an array, but there are specific characteristics between various types of collections. So generally you have collections such as list sets or hash sets, dictionaries, queues, and stacks. And each one of these have special behavior and characteristics that set them apart from one another. So let's start with the very simplest one that I love to use a lot, called list. So if you think of a list is very similar to an array. But the difference between a list and an array is that a list is dynamic and an array is usually not dynamic. What that means is that I can insert items into a list at any given point of the program's running or execution, whereas with an array, it's a little bit harder to do that because in most cases you would define an array when you know that you have a specified set of values that you want to use and those values won't update as much. So let's go ahead and demonstrate a list. So we have a list. I'm going to create a list of string. And let's see, let's do something different here. Let's say we'll have a list of cities. And again, we will construct or initialize this list with a new keyword and a list of string. So this is how we initialize a new list. Notice that we have a new list and we specify the data type between these angle brackets. And that's basically how we specify the type of data that would be stored in this list. So we want to have a list of cities. And generally what we want to do is we want to add just a couple of cities to this list. It doesn't matter how many. We can add 1, we can add 5, we can add 1,000,000. But I'm just going to add, let's say, 3 of them. So let's say the first city is going to be my home city, New York. The second city will be a very cool one indeed. Oops. Tokyo. If I can spell Tokyo, please don't get mad, Japanese people. And the third one will be Berlin. Okay. So now we have this list of cities. So essentially we have a list of length 3 here. Now, if we want to access these values, it works similarly to arrays. So we can say console.writeLine, and we can say, for example, if I want to grab Berlin, I can just say cities of 2 because we want an index of 2. Not an index of 3, remember, because Berlin, although it's the third item in the list, it's an index of 2 because it's a zero-based collection. So if I run this, we see we get back Berlin, which makes sense. Now, if I want to know the length of this, let's try this. Console.writeLine cities . If I try to write length, you notice nothing comes up. That's because the length property is specific to arrays. If you want to know how long or how large the collection is. In the case of collections versus arrays, with collections, you would use the count property instead of the length property. So if I do cities.count and semicolon and I run this, we see that we get back a count of 3. And just to make sure that everything looks good here, and I'm just going to add another city. And I'm going to add Sydney, Australia, right? Sydney. So if I go ahead and run this again, we see we get a count of 4 this time. That's because we have 4 items in the list. So that's basically list. And one other thing I'll point out about list is that list can contain duplicate values. So just keep that in mind. You can actually have multiple Sydneys in there, multiple New Yorks in there. Nothing will ever happen because lists are dynamic and they allow duplicates. Now, I want to move on to another collection type. I guess we can move on to hash set. Well, actually, you know what? Before I do that, let's go ahead and show you how to loop through a list. That works very similarly to looping through an array. You can actually use a for each or for, or you can even use a while loop if you had a counter variable. You can use any loop possible, but in this case, I love using for each. So for each, we're going to loop through each city and output them. In this case, we are storing strings. So we're going to specify that each temporary variable will be a string data type. And we're going to just say city in keyword cities. So for each city in cities, all we want to do is console.writeLine, and we're going to just say city. So if I run this, you're going to see that we get every city outputted to the console. So it's just that simple, guys. Like the for each loop in tandem with collections, it's super powerful and super rudimentary. It's very easy to use in most cases. So let's go on and move on here. Now you have a collection type called hash set. And what a hash set does is it allows you to store values just like a list, but you are not allowed to have any duplicates in a hash set. And what I can do is I can show you how that works. I guess I'll show you that before a dictionary, but let's go ahead and do a hash set. So let's say, for instance, we have a hash set. And let's also make that a string data type. And we'll call this countries. Make it simple. It's a new hash set of string. Perfect. See, that auto-populated it for me. All right. So similarly, we can add values to this country's hash set like this. We can say countries.add, and let's say Germany, countries.add, and let's say USA, and countries.add. Something happened there, countries.add, and let's say Japan. Okay. All right. So now, again, if I want to find out what is the length of this, I can say console.writeLine, and I can say countries.count. Okay. And just to kind of, separate this here, just so we know that this belongs to this, let's just have a string literal here and just say countries. Oops, I misspelled that. Countries count. So we know what that is, plus sign. All right, so if I run this, we see we have a count of 3 in countries count. That's because we have 3 items in the set. Now, what I want to show you, what I meant by that duplicates are not allowed. Let's say if I were to come here and I were to add, and I'm just going to copy, let's just say if I copy this line, this Japan line, or even, you know what, let's copy the USA line. I'm patriotic. So let's copy this and paste it here. What do you think the outcome is going to be? If I run this, you see it still outputs to 3. Why is that? Well, that's because even though I added a second USA item to the set, to the hash set, hash sets do not allow duplicates. So that's the reason why that didn't work. It looked at the current, it searched through the entire hash set for an existing USA value, found one and said, well, this is a duplicate, let's not insert this. So you generally would use hash sets if you want to ensure that the data that you're putting inside is not duplicated data. So this is very powerful in a sense. And again, to loop through a hash set, we can use a for each. So we can say for each country in countries. Let's get my braces correct here. And what we can do here, let's just console dot right line, and let's just output the country right here. And save and run. So we get an error message. It looks like one of our braces is screwy somewhere. Where is this happening? Am I missing one? Okay, let's try that. There you go. So there we go. So we see here we're outputting Germany, USA, and Japan. So again, for each loop works very similarly, really no difference. It's the same structure, the same syntax, and so on. So that's basically sets. So again, you basically would use a list when you want to have duplicates in the collection, and you would use a set or a hash set when you don't. All right, when you don't want to have duplicates. Now there's an even more powerful collection data structure that exists in .NET, C#. It also exists in other programming languages, and they're referred to as maps in other languages, but in C# it's referred to as a dictionary. And what a dictionary is a key value pair collection. So it's a collection that has key value pair entries, and what that means is the key is usually unique. It doesn't have any duplicates, whereas the associated value with that key can have duplicates. And you would generally use this data type when you want to access data that could be repetitious but differing based on the key. Or you might want to use it to quickly index sets of information. So let me just demonstrate. I think the best is through writing some actual code. Best way to demonstrate. So as you see here, I already started typing and I'm getting dictionary, but I'm going to type everything out by hand. I'm not going to use the shorthand here. So I'm typing out dictionary, and let's see, what do we want to do here? Let's make a dictionary of a string key type and an integer value. And basically we're going to have a dictionary of age, of various ages of people. So we're going to call the variable age dict, and we're going to use the keyword of new, and we're going to say dictionary, I hope I'm spelling that correctly, string int. All right. So to define an entry, which is a key value pair, we just simply would specify the keys and then assign the values to each key. Now I'm trying to think of how I can best do this in the cleanest way possible. And I think the best way to show you this is, let's just start off by defining a string variable. And I'm going to do it, and you'll see what I'll do in a second. So I'm going to define a string variable and call that the dictionary key, and I'm going to just put the name of Alice in there. So that's going to be the name of a person in there. And now what I'm going to do is I'm going to say age dict is going to be dict key, index of dict key, and I'm going to specify that as 30. So basically, let me explain. What I'm doing here is I'm inserting the value of 30 as a value with that should be associated to the key of Alice. So it will look something like this. It will look like, let me see the best way to describe this. Sorry. Let me just do that here. The best way to describe that is this. Let's imagine you have this structure, and this is the key, Alice, and then you have an age of 30. And then if you were to add another entry, it may be like Bob or something like that. And then you have an age of, let's say, 75. And this is a dictionary because all we need to do, let's say if we want to grab Alice's information, and it just doesn't have to be an integer, it can actually be another object. It could be anything. But let's say if I want to grab Alice's information, I could just say in the age dict, give me Alice, and it will give me all of the associated data that's after this colon for Alice. In this case, it would just be the age. So that's basically how that works. So now moving along here, let's say if I want to use a control statement, let's say if I want to use an if statement to check if Alice exists. And this is a common thing you would do when working with dictionaries. So let me just show you. If I say age dict, there is a function that's part of the dictionary class called contains key. And the contains key method we'll check to see if a specific key, I don't want to say value, but if a specific key is a part of a dictionary entry. So here what we want to say, and this is the reason why I stored Alice in the variable so I don't have to retype Alice. I can say dict key because again, that's still Alice, the value of Alice. So I'm basically saying in this dictionary, is there an entry with the key of Alice? If there is one, I want to say console.writeLine. Let's see. Let's output Alice's age. Let's do something very interesting here. So let's do a formatted string. I'm just going to put a semicolon here before I forget. And in that formatted string, we're going to have a curly brace and we're going to say, let's say Alice. So again, that's the dict key. That's Alice, right? That's the name of Alice. I'm going to just do apostrophe S. Just follow along, guys. And the age. And we're going to output the age. Now, we output the age by saying age dict, opening and closing square brackets, and then we put dict key. So basically, that's going to fetch for me the integer age, which is in this case going to be 30. So I'm not sure if that's going to work, but let's give it a shot. Let's run it. And it did work. So Alice's age is 30, as you see here. And basically, I use string concatenation to insert Alice's name, which is stored as dict key. That's the variable. And then basically, I'm getting her age by just referencing that dictionary and pulling her entry out by the key. So in that case, because it exists, it executed this if statement. But what happens if we don't have that value? Then generally you would just have like an else here to do something else, right? So you might have a common sort of logical flow here is to have an else statement in which you would insert a value into the dictionary if it doesn't exist, especially if you're working within a for loop context. So that's like a very common thing you'll see in programming. But in this case, we don't want to do that. We just want to continue with what we were doing here. I just wanted to demonstrate that. So now, let's say if I want to output everything that's in the dictionary, I can do that with a simple for each. But before I do that, let's just, let's maybe just add one more person to the dictionary. I'm just going to add it in. I'm not going to define another string variable. So let's come up, where were we here? We were here. I'm just going to add another person here. So age dict, let's say Bob, and Bob is 75. And let's just add one more person, age dict, and let's say Tracy, and Tracy is 18. Okay. All right. So now what I want to demonstrate is exactly how do you iterate through a dictionary. It's slightly different. The reason why is because now we're working with key value pairs. We're not just working with simple primitive data or simple objects. So to do that, we can still use a for each like this. So we can say for each. But what we would do instead here is we would, instead of saying int or any specific data type, we would use the var keyword. And what the var keyword is sort of like a generic data type. It's basically specifying we don't know what the data type of this entry is. So let's just use var. This is a common convention in C#. So I'm going to say var entry in age dict. So for each entry that's in the dictionary, we want to do something. Now, what we want to do in this case is we just want to output the key and the value. And to do that, let's just say console.writeLine. We're using that a lot today. And we're going to say key. And we're going to specify the key by saying entry, which is the temp variable, dot age. Sorry, entry dot key, not age, sorry. Entry dot key. And that's going to give us the key of this entry. And similarly, to grab the value, we're going to say console.writeLine, and we're going to just call this value. You're going to say entry.value. Let's see if that works. So if I run this, as you can see, we're getting the key and the value for every single entry in the dictionary. So yep, this is perfect. It's working. And again, This is very, very, very powerful. You would generally use this in many contexts where you'll have groups of data that you need to index with one another and so on. So as you can see, you can do a lot of things with dictionaries. And I hope that this all makes sense to you because it's a pretty complex topic, but it is a mandatory one for you to understand when working with data in C# or any programming language for that matter. So let's move on. Now, the next two types of collections are not used as often, but they are used. So let's cover queue. Now, what a queue is first in and first out. That means whatever I add to the queue, when I remove from the queue or when I dequeue it, it will be the first entry to be removed. And again, it's not as common, but you generally would use this if you want to keep things in order and you want to know what was the first to be entered and what's the first to be removed from a collection. Then I would use a queue for that. Let me just show you a quick example. So let's say that we define a queue by using the queue class in .NET, and we're working with strings again. And let's say that I want to just define queue. We'll just call it queue, okay? And then again, we want to initialize this queue object. So we say queue of string. Cool. Now, what I'm going to do is I'm going to add, or I'm going to enqueue. You wouldn't use the add, so I'll show you. For example, with queue, you wouldn't say queue.add. That won't work. That works for lists and hash sets, but it would not work for queue. Instead, you would have to say queue.enqueue to add an item to the queue. So I'm just going to say first here, so we know that this is the first item of the queue. And let me just copy this line, and I'm going to paste it 2 more times below. And then the next item will be second, and then the final item here will be last. Or you know what, let's just say third. Okay? Now what I want to do is I want to iterate through this just to kind of show you guys exactly how this works. So I'm going to use a while loop in this case to do this. So we'll say while, and generally to remove from a queue, when you remove an item from a queue, which is a very common thing to do when using queues and even using the next collection data type we'll cover. When doing that, generally we have a way of keeping track of the number of iterations. So we don't necessarily need to specify a counter variable here. Instead, what we can do is say queue.count. Because every queue has a count similarly to every other collection. While the queue count is greater than 0, we want to do something. So as long as there's something in the queue, we want to continue doing something. And generally what we want to do here is we're going to say string item, and we're going to remove or dequeue, let's use the right terminology here. We're going to dequeue this item from the queue. Like that. So we have a function or a method called dequeue, which is part of the queue class in .NET, which is responsible for removing a specific item, usually the first item, from the queue. Because remember, a queue is a first in, first out sort of structure or collection. So now by doing that, I should be able to console.writeLine, and what I'm going to do is, just to keep things clear, I'm going to just say queue item, and this queue item will be the item here, the item variable. Cool. So if I run this, you can easily see here that this is working, because what happens is as soon as we remove from the queue, then in order from first in, first out order, the first item is removed, then the second item is removed, and then the third is removed in order. So that's basically how queues work. And with queues, you also have the other properties such as length, not length, but count. As I mentioned before, you just don't have the add one. Instead, you have to use the enqueue and dequeue to add and remove items respectively. So last up here, the last collection I'll cover here is called a stack. Again, it's not used very often, but basically a stack is a last in, first out sort of structure. So whatever is the last item that's being added to the stack will be the very first item to be removed. So you can think of this in terms of a stack of paper. So if you stack up a lot of paper one on top of another, then the very last sheet of paper that you put at the top of the stack will be the very first one to be removed in most cases, especially in the case of printing using a printer. So let's create a stack object here. We're going to use string again, just to kind of show you, just to kind of visualize what we're seeing here. So we're going to call the variable stack, and it's going to be equal to new stack of string. Now, similarly to above, we're going to create a stack. We're going to create stack items, but again, we cannot use add, doesn't work, and we cannot use in queue because it's not a queue. So there's a special method only specific to stacks called push. So we're going to use push to push an item onto the stack. So we're going to push the first item onto the stack. Let's copy this line and paste it in 2 more times below. And let's change this to second and change this to third. Okay. So now, guys, what do you think is going to happen when I iterate through this? So you can pause the video and write out the loop right now if you want. I'm just going to continue. I'm going to say while. And similarly to what I showed above, you don't need a separate counter variable. You can just simply, in this case, use stack.count is greater than 0. Okay, so while the stack count is greater than 0, what we want to do is we want to remove an item from the stack, which is usually going to be the very last item that was inserted, and that's called popping an item. So let's say string item stack dot pop. So we're going to pop this item off the top of the stack, and let's just console dot write line. And what we want to do is we're going to just say stack item, and we're just going to say item. Okay, so if I run this, now if you look at the difference here, let's just examine this. In the case of a queue, it was first, second, and third in order because it's a FIFO, or a first in, first out structure. But in the case of a stack, it's a LIFO, a last in, first out structure. So the very last item that was inserted was this third value, and that's the very first one to be popped off the stack. Then the second value was popped, and then the first value was popped. So that's basically how queues and stacks work. Again, not very common within C#, but they are used from time to time to sort of control the order of how things are, managed. So folks, we almost covered everything we needed to cover. There's just a few more concepts and ideas I need to go over with you. So the very next thing, we're just going to do a quick touch point on methods. Now, we've been using methods the entire time since we've been building this program. But I definitely want to kind of go a little bit more in depth about what methods truly are. So up top in our main method, we'll define a new method called methods. And we'll come right back down to the bottom here. And again, just doing this alone is creating a method. So I'm pretty much demonstrating it right now. So methods, cool. So in here, what we want to do, and let me just explain a little bit about methods. So methods represent the behavior of your application. A class can have state and a class can have behavior. The state is represented through fields and variables, and the behavior is represented through methods or function calls. So generally, in no matter what object-oriented programming language you're using, you'll generally have functions or interchangeably named methods that will control the behavior of your application. So in this case, what I want to demonstrate is I want to say hello to the user. So I'm going to define a new method here called say hello. We're just going to do a simple method. And as you can see, as usual, I have an error message here with a squiggly line underneath saying that this does not exist. And so what we have to do is we have to define what the method looks like. So let's just make this nice and simple. I'm just going to go below here, and I'm going to define a new method. And this is where I'm going to introduce you guys to access modifiers. So up to now, we've been doing a lot of static void, and then the method name, right? What I want to do now is I'm going to introduce you to some new keywords. So here we're going to say private static void, and we're going to say hello. And basically what I did is I specified that this method should only be accessible within this file or within this class, right? So that's basically what's happening here. It's only accessible within this class. So you use private in that case. There's also access modifiers such as public, which means it's available to the entire application. You also have protected, which is part of an inheritance structure where, for instance, you'll have a parent or a base class that would inherit, that would be inheritable by child classes. And in the child classes, you would define a protected method, or even in the base class, you'll define a protected method that would extend that behavior only to the child classes. An example of that would be, for example, if you want to define a custom exception class and you want to inherit from a base exception class, you can define protected fields or properties within that class if you wanted to. We're not going to go that deep into protected here. Just know that there is usually just two main ones you'll be using, which is public and private. And you know, there's also a default one. If it's default, then usually by default it is public. But in this case, we're only caring about public and private. So what we're going to do now is we're just going to output to the console. Let's say console the right line. And basically what I just want to show you is how it works. Now you've been noticing this the entire video. I'm spelling right line incorrectly, sorry. Let's just say hello there, right? So again, kind of the same thing we've been doing up to now. So let me just go ahead and run this and see what we get back. All right, so we get back hello there. So that's nice and simple. That's the simplest way to explain it. Even though this is marked as private, we can access this method because it's within the same file, within the same class. Okay, so generally that's the reason why we can access this say hello method. If this were in a different class and it were marked as private, we would not have access to this method. We would either have to define it as public, or we would have to like set up a certain kind of structure where we can get access to the underlying function. I'm not going to go too deep into that in this video. Just understand that 9 times out of 10, you'll just be marking anything as private if it's within the same class and does not need to be accessible to other parts of your application. And you would set public methods whenever you want it to be globally accessible. That's generally how it works in a nutshell. So let's go back up here. What I want to do is let's define a couple of variables. I want to demonstrate some other things. So I'm going to define a variable, an integer variable where a is equal to 10, and then b is, let's say, equal to 20. Okay. Now, what I want to do is I want to get the sum of these numbers, right? So this is a case where, and I'm going to show you this. Let me just write this out. So let's say int sum. And I'm going to define a new method called add, right? That will add these two numbers together. Now, as it stands, if I defined it like this, there's just no way for this method to know what these values are. So what I would have to do is I would have to pass these values in as arguments or parameters to the add method, and then define this add method and specify the parameters and their data types within the method signature. Let me show you what I mean. So I'm going to pass A and B into this method, and then I'm going to come down here, and below this say hello method, I'm going to define another private method. So let's just say private static. Remember, it has to be static because I'm calling it from within a static context in the same file. And then we'll just say add. Now, I definitely have to specify. I can't just say A comma B. Excuse me. What happened there? I can't just say A comma B. I actually have to specify the data type. So let's say int A comma int B. So these are the two arguments that are being passed into this method. So with that being said, I can now access these values within this method. You know, so basically value by reference here. So what I can do is in here, we could just return. Actually, you know what? I'm just going to console.writeLine first. You know what? No, actually, because I defined it, what we want to do up here, guys, sorry about that. what we want to do is right here, I want to return the sum of this. So now I'm going to introduce you to return types. So up to now, we've been using void, which means that we're not returning anything to the caller method. That's what we've been using up to now. So this time I'm going to return an integer. So instead of void, I'm just going to specify int. And you can return various different types. You could say string. You can return a type. For example, if you had a person class, you could return a person. It's all up to you. You could return anything that's built in or anything custom as part of a return type. In this case, I want to return an integer, a number, so I'm going to specify an int return type. And all I'm going to do is just say return keyword a plus b. And that's going to do the calculation for me. It's going to add a and b together and give me the value to be returned to the caller. So now if you go back here, if you think about this in the sense of baseball, I'm throwing A and B as baseballs to this add method, and then this add method catches it like the umpire would, and then it would return it or throw back the ball to the caller or the pitcher, in this case, which will be this line up here, this int sum equals add. So in here now, in this int sum, I should have the return value that's returned from the add function. So all I'm going to do is I'm just going to console.write line, and I'm just going to say sum, and we're going to just output the sum. And let's see if that works. And like magic, we get back 30 because 10 plus 20 equals 30. So that's working perfectly. So now you know how to work with void methods or voided methods, and you now know how to work with methods with return types that are non-nullable return types. Let's just see. I think that would be it for that. I mean, generally, that's how it works. You've been working with methods all the way up to now. So I would say let's move on to the next thing here. And generally, what we want to cover next are classes, because this goes hand in hand. So let me go all the way back up to the top again. And under methods, we're going to define a new method called classes. So now things are going to get a little bit more advanced, guys. So just bear with me. Maybe rewind this video over and over again until you understand it. But I'll try my best to make things as clear as possible. So now, what is a class? I mentioned it at the beginning of this video, but a class is essentially a blueprint or a template for an object. It basically defines state and behavior, the state being represented by fields and properties, and behavior being represented by functions or methods. And we use classes to separate concerns as well as to define the architecture of an application, making it easy to work with various objects. That's the reason why C# is an object-oriented language. So let me demonstrate right now how to work with classes. I'm going to define another private method, private static, void classes. All right. So this is the method that we're calling above. And to work with classes, what we'll need to do, let's create a brand new class. So I'm not sure if you're working with Windows, but on a Mac, you just need to figure out how to do this on Windows. On a Mac, to create a new class, you would click on File and New File above here. So you should see File at the very top, New File. And you'll see this method or this window pop up. We're going to choose Empty Class here. And at the bottom, we're going to give the class a name. So instead of empty class, we'll change that to person, because we're going to define a person object or a person class. And if I click on create, now we'll see that we have this person class in here. Now, one thing also to notice in here, we have the references to the system namespace as we had done in the program file, the program.cs file. But we also now have a defined namespace. So this is a custom namespace that we're defining so that way we can separate any potential conflicts between classes, other classes that may be named person. So this person class belongs to the C# crash namespace. So we can easily either type C# crash.person to reference this, or there's an even sleeker way of doing it. And I'll show you this in a second to reference this class. So in this class, it's defined as public, making this available globally in our application. If we want to hide this class, we can simply specify private, but that wouldn't make sense in this case, so let's just leave that as public. So we're saying public class person, and in here, in this class, we see a constructor. This is actually called a constructor. And what this constructor is this constructor is basically if the initializer of a person object. So in this constructor, you can do things like assign values to a property or to a field that's located within this class, or you can set initial values. You can instantiate other objects. There's many different things you can do with a constructor. If you want something to automatically initialize whenever this person object initializes, then you should definitely put this in a constructor, or at least consider it. What I want to do in this person object is I want to define the state and behavior of this object. So let's get started with that. The very first thing I'm going to do here, and I'm probably going to copy some code I wrote on the side here just to kind of save some time, but we'll try to type out as much of this as we can. So the very first thing here is I'm going to define some fields. So for now, let me just get rid of this constructor, so that way it's not taking up any space. What's going on here? Okay, here we go. So the very first thing I'll define here is a private field. So private string name. And basically what this is this is going to be just a field that's accessible to this class. It cannot be accessed outside of this person class. And you'll see why I'm doing this in a second. The second one will be private int age. So we're defining an age field. So these are called fields, okay? Now you do have a concept called properties, which I'm going to show you in a second, because there's many ways to define the state here. Let me just add a comment. And by the way, guys, to add comments, I should have explained that earlier. You can use a double / to define a comment. What a comment does is allows you to document your code, so that way other developers and yourself would understand and know what's happening in a certain section of your code block. Generally, comments are not viewable within the browser. But you definitely might want to add some comments to just, for some clarity, just to make things a lot clearer to other developers. So we define these two fields. The next thing we're going to do is let's go ahead and redefine our constructors, but we're going to make them a little bit different. So let's say constructors, and the first constructor here will be public person. This is how you write a constructor. And in this, what we want to do is whenever we initialize this constructor, we want to pass it a name. Excuse me. We want to pass it a name and an age. So we're going to say string name and int age. And doing that will allow us to initialize these fields above. So to initialize these fields with the values that we're passing into this constructor method, what we can do is simply say this dot age is equal to age. And just above that, let me also say this, just to keep things in order, this dot name is equal to name. And now by doing that, what we're doing again is when we say new person in somewhere else in our application, we're going to pass the name of that person and the age of that person to this constructor, and then this constructor will take those values and assign them to these fields up above. So that's generally how it works with constructors. This is a common convention that you'll see in most programming languages. Now, one thing I want to specify that's unique to C# is the concept of properties. And a property allows you to set mutators and to set accessors within a class, so that way they're not 100% fully public in some cases. In this case, I'm going to leave things as public just so it's nice and simple, but you can also set private properties if you want to, make certain things hidden toward other classes, like you don't want to expose certain data points and so on. So what I'm going to do is I'm just going to paste in this code below, and I'll kind of walk you through what's happening here. So below this constructor, I'm just going to go here and I'm going to paste this code, and you guys can type out this code as I'm explaining it. And what I did here is I added these two properties of the same name and age. Notice that they are capitalized versus the fields which are lowercase. And basically what's happening here is when I pass in these values through the constructor and I set these values to the fields above, These properties will then take this value. If I add a value directly to this property, it will set the field value to be in equality with the field above. So for example, if I say person.name, the capital N, is equal to Ron, then it will automatically assign that value that's assigned to the field above, which is the same, Ron. That's what this set function does here. Now the get function is the accessor, and it will return the field name back to the caller. So if I say person.age or person.name, is going to give me the age and name respectively of the person object. Now, in some cases, this is not fully necessary to do it this way. I'm going to show you guys another way to do this. But keep in mind, if you do it this way that I'm going to show you, then you generally would not need to have the constructor call here. So let me just also show you this. So generally, what you can also do here is, I'm just going to add a comment here. Make sure I'm out of that. Say alternative way to set properties. So what you can do is you can actually set them directly like this, implicitly. So public string name get set, just like that. And you can do the same thing for age. And I'm going to explain the difference in a second so you guys understand exactly what I mean. Okay, I'm having some issues here. 1 second. Okay, cool. All right, so age get set. Now, what's the difference between the two? Well, the difference is, in this case, if I don't need the constructor. See, the reason why I'm doing this above is because if you notice, we have this lowercase name and this lowercase age. These are basically the fields that are above here. So basically, kind of the flow here is when I call new person, and then I pass in a name and an age to the constructor above here, then we're setting these field values in the constructor, and then automatically the values get set to these properties as well, okay? Whereas in the other case, if I just specify it like this, then I won't really need to define the constructor, and instead I would directly assign the values like this. Externally, outside of this class, you would do something like person.name is equal to, Billy. And this is going to error out because I'm not in the right context, but that's fine. I'm just demonstrating. So generally, that's what you would do. Instead of passing it to the constructor, you would assign it directly if you're using this method. Now, it depends on what your preference is. I'm going to stick with the other way just because I wanted to show you how constructors work. And to be honest with you, I feel that it's a better architectural design. That's just my opinion, using the constructor plus the property. But you could do it the way you feel is the best way to do it. So let me just clean this up. And what I'm going to do here, is I'm going to comment this out. So that way that's out the way. So that way you'll have that in the future. Okay. All right, so let's move on here. So now we've defined our properties and we've defined our fields. The next thing I want to do is, so we've already defined our state. Let's define another method that represents behavior. So I want to greet. I want to be able to greet the user when we call person.greet. So I'm going to create a new method called greet. So let's make sure we're doing this within the context of the class before this ending curly brace. And we're going to say public. And remember, we have to say public because we want this to be accessible outside of this class. So we say public void and greet. And one thing I want to highlight before I jump in here, notice I'm not using the static keyword here. I'm just saying public void greet. And the reason why we're not using the static keyword is because the intent of this class is that this class should be instantiated, or we should create a new object that is a representation of this class. That's the reason why we don't necessarily need the static, because we may want to use this class over and over again, but in different areas and at different times of our application flow. So we don't necessarily want to keep it in memory that amount of, a very long time. We might want to destroy it, which happens automatically through garbage collection efforts, but that's a whole nother topic. So let's define this public voided method. This won't return anything, so that's why it's void. And instead, what we're going to do, or what we're simply just going to do, is console.writeLine, and we're going to greet our user. So we're going to create a formatted string. Let's close it off with a semicolon, and let's say hello. My name is, and we have two options here. We can use the lowercase one, or we can use the property, which will be my preference, because then we'll be guaranteed that everything is in sync here. So we're going to say my name is name with the capital N, and then I am age with the capital A, years old. And now we're going to save that. So now that pretty much defines our class. So now we can use this class anywhere. So now let's go back to our program.cs file here. And basically what we want to do is we want to call this method within this, wherever we're calling say hello, right underneath that, actually right here in the methods method, we're going to create a new object. So let's do that. We're going to say person, let's just say person. Actually, you know what? Let's make it simpler so that you know what we're talking about here. Let's say person P is equal to new person. And if you recall, we have a constructor that expects a name and an age. So I'm going to give it a name. Let's say Jerry, and the age will be 45. Okay. Now, if you notice, we're getting an error message because person is not being recognized here. And the reason why it's not being recognized is because currently .NET doesn't know where to find the person class. So what we actually have to do is similarly to what we do with the using system, we actually have to bring in this namespace up top. So let's import that by using C# crash, semicolon. So now if I scroll back down here all the way to the bottom, where is it? Now you notice that it's gone. Now you notice that everything looks fine. Okay, so now the person is being recognized, and that's because we defined a namespace in our person class of C# crash. So now if I want to call the greet method, I just simply say P, that's the variable, .greet. Okay, so as you can see, we're having an error message here, and I'm not really sure why. Let's run this and see what's going on here. Okay, so we're having an error message here about a namespace cannot, okay. Okay, so, okay, that's a little tricky here, guys. So let me try to figure out what's going on here. So there's obviously an issue with the namespace. Let's see. Let's go back to our person class here and see what's going on. A little bit of debugging. So we have a namespace C# crash. Let me just copy this as such. I just want to make sure I have that correct. And let me go back here to program up to the very top. That should work. I'm not sure why that won't work. Let's see. Let's run again. Okay, so not really sure what's going on. The problem's line 35. Line 35 of the person class. So let's go back to a person class and see line 35. And this is part of the debugging section of this course. All right. Okay, where I bet you there's a problem somewhere with the let's see. All right, so now this is usually a problem whenever you're dealing with curly braces, and I think it's because it's outside of this class. It's outside of the namespace. All right, guys, I actually found out what the problem is here. So the problem was that my public method was defined outside of the namespace. So if you're having the same issue, what you want to do is go back to your person.cs file, and you want to make sure that this greet method is contained within the class itself. Make sure it's defined within the class. Sometimes the curly braces can be a bit confusing, So just make sure it's defined, and once it's defined, once it's specified within the class, then any error messages or squiggly lines should go away. And if I run this now again, just to kind of show you what's happening, you see that I'm now getting a greeting of hello, my name is Jerry, and then the age of Jerry, okay, which is 45. And basically how that's working is, going back to the program class where we were before, I'm passing in Jerry as a string literal value, and I'm passing in the age of Jerry, and that's how it works. So let me scroll down here to show you guys again. See, as you see here on this line, line 308, this is what's happening. I'm passing in Jerry as the value and the number 45 to represent Jerry's age, and then I'm just simply calling p.greet. And doing it this way, see, if I didn't specify the constructor, then I normally would have to do this. If I had the other properties available, I would normally have to do p.name with a capital and then have to say Jerry like this, right? And then, and so on. That's another way of doing it. But if you don't feel like doing that, you could just simply specify it through the constructor, set up some fields, and then have some underlying properties that you can access the data through. So that's generally how classes work and how the methods and classes come together. So one thing, guys, that I just caught, basically in the methods method above in the program.cs file, I actually filled out these 2 lines of code within that method, and they should have been in the classes method instead. So just make sure you cut and paste those 2 lines, or these 2 lines rather, into this method, because it just makes sense structurally to do so. All right, so the very last topic we want to cover here is exception handling. So let's go to the top to our main method, and let's create the method exception handling. And we already kind of covered this earlier when we looked at the try catch block and we handled the divide by 0 exception, but I want to kind of expand on that a little bit more. Now, exception handling is very important in an application to do. First, let's just specify a new static void method here to set this up, exception handling. So exception handling is very important because you may have some instances where you'll have bugs or errors in your code and you don't know exactly what might be causing them. So just to protect yourself in the code's execution, it's important, it's smart for you to use try catch blocks where applicable, so that your program doesn't stop suddenly. It doesn't just stop execution. The worst thing that can happen is you have a real world application and it's live and it runs over the weekend, and you have to get called into the office or called online to fix the problem just because you don't know what it is. Now you're spending many hours trying to fix the problem, versus having a try catch block and logging that error message to a database. You're able to quickly identify what the problem is and fix it and triage it accordingly. So in this method, what I'm going to do is I'm going to give a few examples of how exception handling truly works. So let's start off by defining a couple of variables here. So I'm going to define 2 integer variables. Int a is equal to 10 and int b is equal to 0. So I think the easiest way to demonstrate this again is by using the same example we used above, but we'll add some more things to it and give it a twist. So let's say, for example, we want to purposely cause a divide by 0 exception just to kind of understand more about the concepts here. So what I'm going to do is I'm going to create a try catch block. So try, and within the try block, I'm going to say int result is a divided by b. This is going to, of course, throw a divide by 0 exception. So there's no need for me to console write line this. Instead, what I'm going to do is write a catch here. I'm going to say divide by 0 exception of ex. And in here, I'm going to say, let's just do ex.message. So if I run this, then we see we have the error message attempted to divide by 0 as we had above. Good. All right, so what I want to show you now is that we can actually expand further on this as well. There's actually something called a finally block, and basically what a finally block does is it actually executes despite what the outcome is. Whether there is an exception or not, it will always execute at the end of a try catch. So to demonstrate that, let me set up a list of string. So list string, And in this list, what we want to do is, let's just have a list of shapes, the names of shapes. So new list of string. And in here, we'll just do a shorthand initialization. And in here, I'm going to just add a couple. Let's just say square, rectangle, and circle. Right. Now in here, I'm not sure what's going on. Okay. So we have a list of 3 items, and generally what we want to do is, let's say for example, we want to grab a 4th item. Now we know that that does not exist, and that should throw some sort of index out of bounds exception. So let's write a try catch. And this again may be a scenario where you don't necessarily know what might happen in production. In a production environment, you may not know at any time how many items are in a list, for example. So that's the reason this is a good use case of a try catch. So in here, let's say if I want to try to console.writeLine, and I want to try to get, let's make it simple so it's clear, the 10th index. We know that doesn't exist, so there should be an exception message, and we want to catch that. Now, we don't know what kind of exception it may throw. So what we can do is we can use the base class definition of exception, which is just called exception. This is a built-in .NET framework class that every single exception class inherits from. So it's the parent or base class. So we're going to say exception of EX. And in here, we're just going to say console.writeLine. And let's say this index does not exist. And let's just also output the message just to make sure. All right. So now what we can also do on top of this is we can actually add a finally block. And what this will do is this will execute even if there is no exception. So whether there's an exception or not, it's always going to execute. So finally, at the very end of this execution, let's just console.writeLine, all code has been run. All right, and save. Now let's try to run that and see if it works. So as you see here, the very first thing we see is we're getting an exception because we attempted to access an index that does not exist. And then the very final thing we see here is the all code has been run. So that basically means that the finally block has executed even though there's an exception here. Now what we can do is to test to make sure that it works the other way around. Let's try to grab the 0th index, which will not cause an exception. If I run this, you'll see that basically the square gets outputted, which is in the 1st index or the 0 index, and then all code has been run gets outputted to the screen. So that means that it ran even though there was no exception thrown. So that's basically how that works. Now, a more complex example, I'm just going to copy some code just to kind of show you a more realistic example of how you would use this. So just bear with me for 1 second. Let me grab it and So what I'm going to do here is I'm going to walk you through what this example looks like. So I'm just going to come down here, make sure I'm putting this in the right place, and paste. Okay. So what this code is doing here, the very first thing is I'm setting a Boolean value of isStudent is equal to false. So basically this person is not a student. Then in the try catch block, I'm checking to see if the current user is a student. If the user is a student, we're just going to output that the user is a student to the console. If the user is not a student, in the else block, we're going to output a specific type of exception, which is going to be one that we'll create in a second. And I'm going to call this custom exception. So as of right now, you're seeing that this is an error message because this does not exist. This is not an actual .NET exception class. So in .NET, we can actually create our own exception classes, and I'm going to show you how that works in a second. So this exception class will take in an argument, which is this string literal. You cannot enroll in this class, essentially. And then finally, we catch the exception if it occurs, right? So we're just outputting that exception message to the console. So what we have to do now to make this fully work is we actually have to create another class. So we're going to go up to the top here and say File, New File. And we're going to create an empty class. And down here, we're going to call that class Custom Exception. So it's Custom Exception. And then we're going to hit Create. And so now we've defined this class. Now in this Custom Exception class, we're going to want to extend the behavior from the base class to a child class. So this exception class will essentially be a child class of .NET's base exception class. And to do that, all you have to do is to demonstrate inheritance. You just do a colon and the name of the parent class right after the colon. So here we're basically saying that this custom exception class that we're creating is a child class of the base class of exception. Now we have access to all of the methods and properties and fields of the exception class. Whatever's marked as public or protected will be accessible here. So in this exception class, we want to basically have two constructors. We want to have this default one here that does not take in any arguments in the event that we don't have any arguments to pass in. And the use case for that would be if we just want to output the entire stack trace or the entire message. We don't want to specify any special message. We may just give it a no argument constructor. But we're also going to define another constructor that takes in a message from the caller. So how we do that is we say public and the name of this class, which is custom exception. And then we give it the arguments. So it's going to take in a string of message, which will be the exception message. And to make this work perfectly, we need to also extend the base class's method constructor. So we're going to say base, and we're going to pass in message to the base class's constructor to make this work. So the curly braces, and we don't have to put anything within the curly braces. It's pretty much done. So now let's go back to our program class. And I'm thinking everything should work. So let's just give this a shot. Let's run this. And as you can see here, we're seeing that you cannot enroll for this course. And the reason why we're seeing that is because we are getting an exception message because this is not a student. So it's hitting this catch block down here and it's outputting this custom exception instance or value, passing this into the instance of custom exception and outputting this to the console. So this is working. So now you can truly see the real sheer power of .NET and what it does. How you can extend behavior to child classes. This is known as inheritance and polymorphism. Inheritance is the act of creating a child class and inheriting from a base or super or parent class. Those words are interchangeable. And then polymorphism is the act of an object taking on many forms. So folks, that pretty much sums up the C# and .NET programming language. Hopefully you had lots of fun coding along with me. The source code for this course is in the description below in my GitHub repo. You could just simply clone the repo and you'll have access to the code examples and things like that. I want to thank you for watching this video and following along. Make sure you like the video, subscribe to this channel so that I can keep doing my thing to bring you great course content. Have a great day. Happy coding.